Welcome back, everyone. Get ready to dive deep into the world of material science, because today we're talking about stuff that's tougher than your average diamond.
Yeah, and we'll uncover how seemingly insignificant things can have a huge impact on performance.
It's all about cubic boron nitride, better known as CBN, right? This stuff is a workhorse in the world of abrasives.
Absolutely. It's used to grind and cut some of the toughest materials out there.
Now, our listener is really interested in how we can actually analyze CBN at the elemental level. They sent over some information on a technique called GDMS. Sounds pretty high-tech, right?
It is. GDMS stands for Glow Discharge Mass Spectrometry. It's an incredibly powerful technique that allows us to see what elements are present in a material, even in super tiny amounts.
So we're talking like a super-powered microscope that can spot even the tiniest trace elements. Kind of like a detective looking for fingerprints at a crime scene.
Exactly. Imagine trying to find a single grain of salt in a giant sandbox. That's the level of sensitivity we're talking about with GDMS.
Wow, that's pretty impressive. But why would knowing about these trace elements in CBN matter so much? I mean, we're talking about ridiculously small amounts here.
Well, you might be surprised to hear that even these tiny amounts can have a big impact on the way CBN performs. It's all about understanding the influence of impurities.
Impurities, like what kind of impurities are we talking about?
Things like oxygen, silicon, even aluminum can sneak their way into the CBN structure. And depending on what's in there, the properties of the CBN can change dramatically.
Okay, so give me an example. How do these impurities actually affect the way CBN works?
Sure. Let's say you've got CBN with a little bit of oxygen in it. Now, this might sound counterintuitive, but oxygen can actually make the CBN less effective when you're trying to grind certain metals. It's kind of like weakening its cutting power.
Interesting. So oxygen is a no-no. What about other elements? Are they all bad news?
Not at all. Some impurities can actually be beneficial. For instance, if you have a touch of silicon in the CBN, it can actually make it more stable at high temperatures.
So it's all about finding the right balance. Kind of like adding the right spices to a recipe, right?
Yeah.
You need the right mix of elements to get the CBN to behave exactly how you want it to.
Precisely. And that's why understanding these subtle differences is crucial for companies working with CBN. They need to make sure they're using the right type of CBN for each specific application. Otherwise, they might end up with a material that's not quite up to the task.
I see. It's like using the wrong tool for the job.
Yeah.
Now, the information you sent over mentioned a company that needed to analyze 4 different CBN samples using GDMS. What was the situation there?
So this company had these 4 different samples, and they needed to figure out exactly what was in each one, right down to the trace elements. They were likely trying to do some quality control and make sure their CBN was consistent.
Okay, makes sense. But then they hit a snag. It wasn't easy to find a lab in the U.S. that could do this type of analysis, right? What was the issue there?
You see, GDMS requires some pretty specialized equipment, and not every lab has the capability. On top of that, they needed a lab that was ISO certified, which means it meets super strict international standards for quality and accuracy.
So it's not as simple as just sending your samples off to any old lab. This is where it gets tricky. It's like trying to find a needle in a haystack. Except the needle is a super specialized lab, and the haystack is the entire USA.
Exactly. And to make things even more complicated, GDMS is a destructive technique. What that means is you have to vaporize a small part of the CBN sample to analyze it. So the company had to find a lab that could do the analysis accurately, but also handle their samples carefully.
Oh, so there's a risk you could damage the samples if you're not careful.
Well, there's always that risk, but a good lab will minimize it as much as possible.
So what did the company end up doing? How'd they solve this problem?
They ended up finding a solution through a network of labs. These networks, like the one they worked with, Infinita Lab, are becoming increasingly important because they connect companies with specialized labs all over the place.
So it's kind of like a matchmaker for companies and labs.
Yeah, that's a good way to put it. Infinita Lab helped the company find an ISO-certified GDMS lab right here in the U.S. that had the expertise and the equipment they needed.
That's great. So they finally found the right lab. What happened next?
Well, the lab analyzed the 4 CBN samples using GDMS, and they sent the company back a detailed report with all the results. This report basically gave the company a unique fingerprint of each CBN sample, showing exactly what elements were present and in what amounts.
And armed with that information, I'm guessing the company was able to make much more informed decisions about how to use each of those CBN samples.
Absolutely. They could look at the results and say, okay, this sample is perfect for high temperature applications because it's got a bit of silicon in it, Or this one's ideal for grinding steel because it's got a low oxygen content. It really took the guesswork out of the equation.
That's a fantastic example of how GDMS can be used to solve real-world problems. It's amazing to think that we can get so much information from such tiny amounts of material. I have to admit, I'm still a little bit fuzzy on how GDMS actually works. It sounds like complicated stuff.
It can seem that way, but the basic principle is actually pretty simple. Here's the gist. You take your CBN sample and you put it in a chamber with a special gas, usually argon.
Okay, and what happens then?
Then you create a plasma, which is like a superheated, electrically charged gas. Think of it like a bolt of lightning trapped in a bottle.
Whoa, that sounds intense.
It is. This plasma bombards the CBN sample, and it knocks electrons off the atoms in the CBN, turning them into ions.
Ions. Remind me, what are those again?
Ions are just atoms that have gained or lost electrons, giving them an electrical charge. And once you've got those ions, you can use a powerful magnet to separate them based on their mass-to-charge ratio. It's like sorting them by weight.
Ah, I see. So the heavier ions go one way and the lighter ones go another way.
Exactly. And by measuring how many ions of each type are present, you can figure out exactly what elements are in the CBN sample and in what amounts.
So it's kind of like creating a unique fingerprint for each CBN sample based on its elemental makeup.
You got it. And just like with human fingerprints, no two CBN samples are exactly alike.
This has been super fascinating. It really makes you realize how even the smallest details can have huge implications in the world of material science.
And this is just one example of how GDMS is used. It's a versatile technique with applications in so many fields. We're talking semiconductors, environmental science, even forensics.
Now that you know what GDMS can do, it really makes you wonder what other materials or applications out there could benefit from this type of analysis. It really opens up a whole new world of possibilities, doesn't it?
Absolutely. The possibilities are practically endless. And as technology continues to advance, I'm sure we'll find even more ways to use GDMS to explore and understand the materials that make up our world.
Well said. That's all the time we have for today, but a huge thanks to our expert for taking us on this incredible deep dive into the world of CBN analysis. Until next time, stay curious.